Hello everyone, today I want to introduce my work, Smart Help, Strategic Opponent Modeling for Proactive and Adaptive Robot Assistance in Households. This work is open source, and you can find the code and checkpoints at the provided links. The presentation is divided into 4 parts: motivation, environment, model, and results. Helping is a second-order goal-directed action aimed at increasing the utility of another agent, the helpee, by reducing the cost or increasing the reward of the helpee's own goal-directed action. Previous work mainly focused on cooperation between agents and typical human users, assuming homogeneous capabilities and ignoring vulnerable groups with varying abilities. They also assumed that both the main agent and the helper only cared about task completion progress, neglecting the main agent's feelings when receiving help. Our main contributions can be summarized as follows. We propose a novel Smart Help challenge that aims to learn how to provide both proactive and adaptive help to diverse human users, especially vulnerable groups, based on inferred goals and capabilities. To the best of our knowledge, we contribute the first 3D realistic home environment built upon AI2 Thor, focusing on assisting vulnerable groups with daily household tasks in an online and interactive manner. We provide a benchmark model with joint goal and capability inference, bottleneck reasoning, and helping policy improvement. Rigorous experiments and the proposed holistic evaluations validate the efficacy of our model. Now on to the environment. The Smart Help Challenge aims to provide both proactive and adaptive support to humans with diverse disabilities and dynamic goals in different tasks and environments. It requires the agent to infer both goals and capabilities during interactions with humans. We built a 3D realistic home environment using AI2 Thor. It contains a main agent that imitates human behavior with diverse capabilities and various goals, and a helper agent learning how to provide better assistance to the main agent. Next is our model. Our model includes an opponent modeling module that can estimate the goal and capability distribution of the human user, and a helping policy module that can produce value estimation and action decisions. We use a different reward function for our challenge. Previous work on cooperation and helping tasks usually uses a shared reward, adding own reward and others' reward with a factor. We extend others' reward with emotional responses, adding an extra reward to it. We use Lambda to control the helper's sensitivity to the emotional states of the main agent. We first pre-train the opponent modeling module on a collected data set. Then we freeze the opponent modeling module and train the whole model with reinforcement learning, RL. We use the progressive learning, PL technique. In the first stage, the model learns a general helping policy with L by 0. In the second stage, the model learns to provide customized help with L by 1. Lastly, we come to the results part. For the baseline, we choose random model and end-to-end model as basic models. Then we transfer the state-of-the-art SOTA model in watch and help to our task. Lastly, we also test the performance of large language models, LLM. For ablation, the end-to-end model can be viewed as our model without the opponent modeling module. Then we remove the predicted capability and change the reward setting to test the effectiveness of different components and the learning skill. We use several metrics to evaluate the performance of the models. Among them, the goal conditioned success rate and helping necessity are first proposed by us. Others are adapted from previous work. The goal-conditioned success rate evaluates the degree of task completion at the goal level, and helping necessity evaluates the necessity of helping behaviors. Results show that our model achieves the best performance. Detailed analysis can be found in the paper. We find that after the initial warm-up of the basic skills, setting Lambda CE to 1.0 in the second phase greatly improves the helping necessity, HN, while maintaining competitive performance across other metrics. Here are the takeaways, and thank you for listening.